everyone, Mrs. Garcia here. Today we're going to talk about some prior knowledge needed for Algebra 2. So most of this stuff you probably learned in Algebra 1 or sooner. You probably reinforced it and used it in geometry, but again, you probably learned it in Algebra 1 or earlier. And of course, since this course is called Algebra 2, we do need to know the stuff from Algebra 1. So while there's a lot of stuff on this worksheet, it is going to take me a long time to get through. I'm going to go as quickly as I can, but I do want to be thorough just to ensure that everybody understands this because these are the building blocks for Algebra 2. So let's go ahead and get started. First, operations with integers. So if you struggle with this, some of you have no problem with this and that's great, but some of you struggle, so then I would recommend you thinking of it as money because that generally tends to help. So if I have -1 plus -4 and you don't easily see that that's -5, then think about debt. Think about money. Okay, so if you're $1 in debt and you add more debt to that, of course you're going to be more in debt. So that's -5. Okay, and then 2 minus 5. Again, if you don't easily see that that's -3, think about money in a bank account. Think you have $2 in your account and you take 5 away. You spend $5, then your bank account is going to be, you're going to have an overdraft fee, right? And you're going to be $3 in debt. Okay, similarly here, if you are -$3 in debt and you take away debt, because remember a negative is like debt, so if you're $3 in debt and you take away debt, then of course you're going to have less debt. So some of you may have been taught this KCC for this problem. When you have minus a negative, that's keep it, change it, change it. So minus a negative becomes a positive, and that's great. Okay, so you can see you have -3 plus 1. So that's going to be -2. Again, think about money. If you're $3 in debt and you add $1 to your account, then you're only $2 in debt now. Okay, so there's that. And then, of course, it gets different whenever you're dealing with multiply and division. It's not necessarily the same. So here you kind of just have to remember your rules. So here when I'm multiplying, remember these two parentheses next to each other means multiplication. So I'm multiplying -7 times -8. A negative times a negative is a positive. So that's going to become positive 56, okay, on that one. And then here with the division, we have -12 divided by +4. And you may see it written like that, but you also may see it written like a fraction, like this, -12 divided by 4. Okay, that might be more common. And then you look at it as a division problem. So 12 divided by 4 is 3. 4 goes into 12 3 times. And a negative divided by a positive is a negative, so the answer will be -3. And y'all, I never, ever like working across, but since I have very little room here, I'm doing it that way. I'm making do, but never, ever do we work across in this class. I'm just letting you know. Okay, so operations with fractions is next. So remember here, when you add two fractions, you have to have a common denominator. So 7 and 5 are my denominators. Those are not common. So 7 and 5 are both prime. So that means they're not going to have common factors. Okay, so you need to find the LCD, and when your two denominators are both prime, it's pretty easy. You just multiply the denominators together. So 7 times 5 is 35. And again, that's because they're prime and they don't have common factors. So then my LCD is 35. So to get that common denominator of 35, I'm going to multiply this first fraction by 5/5. And I'm going to multiply the second fraction by 7/7. So this is going to become, we are going to have here 5 times 3, remember numerator times numerator, denominator times denominator. So this is going to become 15, oh, why am I writing this in red? I should be writing my work in blue. This is going to become 15/35 plus 28/35. So now I do have that desired common denominator. So then remember, when you have that common denominator, you add or subtract across the top, keep the bottom the same. In our case, we're adding, so 15 plus 28 is 43. So 43 over, keep that denominator the same, so 35. Okay, so next problem we have subtraction. Still with subtraction, we have to have a common denominator. I look at 6 and 9, those are not common, and they are not prime. Neither one of them is prime. So these two denominators may have common factors. That can be a little bit more difficult because to find the LCD, not just a common denominator, but the lowest one, you can't just multiply those numbers together. Sure, you can do it that way. It'll take longer because you're working with bigger numbers, and there's a smaller common denominator. So let's find it. Remember, if you watch the fraction video, how I do it is I take the smaller of the two numbers and I start finding its multiples. 6 times 1, 6 times 2, 6 times 3, 6 times 4. And I look at those multiples until that number can be divided by this other number. So 6 times 1 is 6, and of course 9 does not divide into 6 evenly. So then I look at 6 times 2. 6 times 2 is 12. 9 does not divide into 12. 6 times 3 is 18. 9 does divide into 18, so 18, ding, 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 is my LCD. So to get 18 as my LCD, I'm going to multiply this fraction by 3 over 3, and I'm going to multiply this fraction by 2 over 2. So then I'm going to have 3 times 7, which is 21, over here 3 times 6 is 18, and then this is a subtraction problem. 11 times 2 is 22, over 9 times 2 is 18. So then I have my subtraction problem, and I have 21 minus 22. Again, that's going to put me in debt, remember? So negative 1 over, keep that denominator the same. So that's my answer on that one. Okay, so then I'm going to talk about multiplication of fractions. So remember, with multiplication of fractions, I like to simplify first. That way I don't have to worry about it at all in the end. So remember, when you multiply two fractions, you can simplify top to bottom. So I'm going to check all the possibilities here. So can I simplify 2/3 top to bottom? No. Can I simplify 15 over 7 top to bottom there? No, nothing divides evenly into both of those numbers. So then I look at my diagonals. So diagonally, 2 over 7 does not simplify, but 15 over 3 does. Both of those numbers are divisible by 3. So 3 goes into 15 5 times, and 3 goes into 3 1 time. So then I go ahead and multiply my numerators and my denominators. So top times top, bottom times bottom. So 2 times 5 is 10. And then 1 times 7 is 7. So then I am done. Okay, now with division, hopefully you've learned something similar to, or you've learned exactly KCF, not KFC, not to be confused with KFC, the chicken place. So KCF stands for keep it, change it, flip it. So I keep the first fraction, I change the division to multiplication, so look at me change it, and then I flip this. So instead of 4 over 25, this becomes 25 over 4. So I'm going to cross that out so I don't even think about that anymore, and I flipped it. So then I act like this is a multiplication problem like I did before. And again, when it's a multiplication problem, after it's multiplied, not while it's divide, then you can simplify top to bottom. So here, top to bottom, does anything simplify? No. Here, top to bottom, does anything simplify? No. What about here, top to bottom? No, 5/4 doesn't simplify. What about here, top to bottom? 25 over 8. No, nothing simplifies, so that means I just go ahead and multiply my numerators and multiply my denominators. So 5 times 25 is 125, over 8 times 4 is 32. And of course, if it didn't simplify before, then it doesn't simplify now, so I don't even need to check it. So we're good on that. So now let's talk about operations with monomials and some binomials. So remember, a monomial is a single term. Like this is a monomial times a monomial, one term times one term. And a binomial is two terms. So this is two terms here added to two terms here. So just so you remember. Okay, so here we've got 2x minus 4x. Those are, in fact, like terms. They are alike, so then we just look at the coefficients, the numbers in front. So here we have 2 minus 4. So 2 minus 4 is going to give me negative 2, and then I keep the x. Remember, that doesn't change because I'm not multiplying. We'll talk about that when we get to multiplying. Okay, next, same, I have like terms here, so I look at the coefficients. The coefficients are negative 3 and 7. Remember, the coefficients are the numbers in front of the variables. Negative 3 plus 7 is going to give me positive 4, and it remains x squared. So those like terms The variable stays the same. Okay, here I want to remind you, when you have parentheses like this, really you need to think about clearing the parentheses by distributing whatever number is in front of the parentheses, or sometimes it's a number with a variable. Distribute that in and then work with it. But in this case, look, this is a positive 1. 1 times all of these terms is going to remain the same. Similarly here, 1 times all of these terms, it's going to remain the same. So really, technically, already right away, you can go ahead and just start combining like terms. So let's do that. So you've got 2x cubed plus negative 2x cubed. I don't like the word cancel because, well, I'll get more into that in class. But I don't like the word cancel. 2x cubed plus negative 2x cubed adds to 0. So that means we don't need to write it. It's gone, okay? And then here we have negative 8x plus 4x. So that's going to combine when we look at our coefficients of negative 8 and positive 4. That's going to be negative 4, and then we keep the variable x. So negative 4x is our answer for that guy. Now, don't be fooled. On this problem, we have a minus in between. Now, this right here is still a positive 1, and none of those terms are going to change. 1 times everything here is going to stay the same. However, negative 1 times these terms here will change both of those terms. So we do need to do some pre-work. Okay, so again, like I said, 1 times these are going to stay the same. But let's go ahead and clear the parentheses since they're not needed anymore. So 2x cubed minus 8x. And then negative 1 times 4x is negative 4x. Negative 1 times negative 2x cubed, excuse me, is positive 2x cubed. Okay, so now I can go ahead and combine like terms. And I've got 2x cubed and 2x cubed. So I look at my coefficients, and that's 2 plus 2, which is 4. And remember, the variable stays the same when I'm adding and subtracting. And then, let me use a different color. Then I've got negative 8x minus 4x. So add the coefficients. Negative 8 and negative 4 is going to give me negative 12, and the variable stays the same because, again, I'm not multiplying. The variable won't change until I multiply and divide. Okay, which, hey, what do you know? That's where we're at. So here I've got 6x times negative 3x. Okay, so similar to adding and subtract, you look at the coefficients first. So 6 times negative 3 is going to give me negative 18. Then I do x times x, which is going to give me x squared. Hopefully you remember the rule from Algebra 1 that when you multiply those variables, the exponents add. And the implied exponent here is 1, and the implied exponent here is 1, and that becomes 2. Now, of course, that rule is only for like variables. They're both x's. If I had an x and a y, it wouldn't be the same thing, so just so you know. So now let's look at this next example. Foil, 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 foil. I'm not crazy about that terminology at all. If you like foil and it works for you, use it, fine. But really, it's a trick, and I don't like tricks. Really, what you need to do is just distribute twice. So distribute the 3x to both terms inside the second parentheses, and then distribute the 1 to both terms inside the second parentheses. So use FOIL if it works for you, that's great. But if it doesn't work for you, then just think about distributing twice. So let's distribute the 3x. That's going to give me negative 15x squared. Remember, I'm multiplying, so that becomes x squared. 3x times negative 2 gives me negative 6x. And then 1 times negative 5 gives me negative 5x. Remember, now I'm distributing this term to both terms. And 1 times negative 2 gives me negative 2. And then I've got an addition and subtraction problem, and I just combine like terms. So these are the only two like terms, and I'll combine those and keep everything else. So this will become, that's a negative 15. Thank goodness for erasable pens. Negative 15x squared. Remember, the coefficients add up to negative 11x. Remember, when you're adding, the variable stays the same, minus 2. And then there you go. Put a box on it, and it's done. Okay, so this division problem here, you might see it written like that. Probably not as much as you'll see it written like this, but I did want you to see it just in case you are encountered with something like that. So really, you'll probably see 4x cubed divided by negative 2x. Really, you'll probably see something like this. And then I want you to look at the coefficients just like we've been doing all along. We typically look at those coefficients first, divide those. What's 4 divided by negative 2? Well, 4 divided by negative 2 is negative 2, and that goes in the numerator. I'm not going to put it over 1 yet because it might not be necessary. And then I look at my variables, x to the third divided by x. Hopefully you remember the rule from algebra that when you have like variables, these are alike, they're both x's, one's not an x and one's a y, they're both x's, then you subtract the exponents when you divide. So here this would be 3 minus 1, which is 2 for an exponent, so x squared. And if that doesn't make sense to you, then expand this. X to the third means x times x times x 3 times over x. So if you've got 3 x's on top and 1 x on bottom, 1 x on top can cancel with 1 on bottom, and you'd have how many left on top? Well, you'd have 2. So that's your final answer. And again, if you need to write it out and see that, then do so. If I'm not making any sense to you, then see me personally. Okay, so then next, here is a true division problem written how we just wrote above. So again, we'll do the same thing where we look at those coefficients first, and here's what kills me. It kills me when I see the answer to this as being 4 in the numerator. Y'all, 3 over 12 is 1/4. I'm not going to put the placeholder of 1 on top yet because we might not need it. I am, however, going to put the 4 on the bottom. Okay, so 3 over 12 is 1/4. And then in the numerator, let's see if we have anything. Let's look at our variables. So we've got x to the 5th over x squared. Remember, you subtract 5 minus 2 is 3, and so we don't need that placeholder of 1 up top because we're going to have x to the third up top. The 1 as a placeholder of a coefficient is implied, so I don't like to write anything unless I absolutely need to. You can call me lazy if you want, that's fine. But I don't like to write it unless I have to. Okay, so here, hopefully that made sense and we're good to go. If not, again, see me. So now for these solving equations, we're going to revert to the back because we obviously don't have space here. So I'm giving you a second to finish writing everything that you're writing, and then here we go. We're flipping to the back. I've already written these on the back. And if you need to pause the video to write them out, then do so. Okay, so here's what we're going to talk about with solving equations. Something like this I'm sure you've seen in Algebra 1. Okay, don't be scared working with fractions. When there's only one fraction, it's not so bad. When there's more fractions, something like this, still not so bad, but when you get to this beast, we're going to talk about something called, I'm going to use red because it stands out. We're going to talk about something called clearing the fraction. And you can frankly use it on anything that has a fraction. You can use it on this problem, you can use it on this problem, but in my opinion, with that only having one fraction, I don't think you need to, but if you want to, that's fine. So what does clearing the fraction mean? Well, it means, well, what you're going to have to do is multiply every single term by the LCD. So if you absolutely hate fractions, the word fraction gives you nightmares, then you might want to use this method. Clear the fraction means multiply every single term by the LCD. So let me explain, even though I'm not going to do it for this one, I'll explain it for those of you who don't like fractions at all. So since I've only got one fraction in this problem, the LCD is just this. So that means I would multiply every single term. This is a term, this is a term, this is a term. I'd multiply every single term by 5, and what would magically happen is the 5s would turn to 1. 1 times 4x is 4x, so your fraction would be gone. And again, I'll show you an example, but this won't be the one I do. Okay, so again, on this problem, me personally, I'm just going to use the old school method. So I'm trying to get x by itself, isolate the x. So therefore, I'm going to draw my line to make myself neat. I'm going to subtract 1 from both sides because, again, I hate the word cancel because it confuses kids when we get later to the harder math, so I won't use the word cancel as much as I can try not to. So plus 1 minus 1, I won't say it cancels, it adds to 0. Okay, so that's 0, we don't need to write it. So 4/5 x equals 24 here. Make sure that x looks like it's in the numerator, guys. We're going to learn, this is linear, we're going to learn a function called a rational function later in Algebra 2 that the x is in the denominator. So please, please, please don't let me think that x is in the denominator. Be very cautious of that because it means something extremely different. So again, just be very cautious with that. So now here, to get this x by itself, to isolate this x, I want to get rid of the 4/5. Easiest way to do that in my opinion, is to multiply by the reciprocal, 5/4, both sides. Remember, what you do to one side, you must do to the other. This 24 is implied over 1. So why do I do this? Because this cancels? No, you'll know I hate the word cancel. Okay, 5/5 simplifies to 1/1. 4/4 simplifies to 1/1. And what's 1 times 1 and 1 times 1? Well, it's 1. We don't typically write the 1 in front of the x. It's implied, but that's what you get. Okay, so we've got x by itself, 1x on the left, and then here, of course, we're going to simplify the 24/4 if we can, top to bottom. This becomes 6, this becomes 1, so we've got 30/1, which is just 30. So stick a fork in it, it is done. Oh no, I'm supposed to write my final answer in red. Oh well, that's okay, I won't do it for these. Okay, so here we go. Again, if you want the clear the fraction method, do it. Find the LCD. 2 and 5 are prime, so that means your LCD would be multiply those two numbers. 2 times 5 is 10. So you would multiply this whole side by 10 and this whole side by 10. Here's what I'm scared of. If you do that method, you multiply this side by 10, the 10 and the 2 will simplify to 5. That 5 needs to distribute to both terms, not just the first term, both terms. Similarly here, if you multiply this side by 10, the 10 and the 5 would become 2. Multiply the 2 by both terms. And we're kind of going to do that with my method, but it looks different. We're just going to use simple cross multiply because this is a fraction equals a fraction. We can use cross multiply. So that means 5 times this equals 2 times this. So when you write it, 5 times, oh, what do you know? Both terms, that 5 multiplies to the 3x and the 1 equals 2 times, that multiplies to both terms, the 4x and the minus 3. Okay, so if you didn't need to write this step out, if you could have gone straight to 15x plus 5 because you knew to multiply, 15x plus 5 equals 2 is 8x minus 6. If you could have done it that way, that's fine. You don't have to write this step out if you don't need to, but just make sure that you distribute to both terms. Okay, so now you've got x's on both sides of the equal sign. That poses a problem. You want x completely by itself. So I look again at the coefficients like I always do. This coefficient's larger, so I'm going to move x's to the left. I could move x's to the right if I wanted, but I like to have a positive coefficient, so I'm going to move to where the bigger coefficient is. So again, 15x minus 8x is 7x. Drag down the plus 5 equals, that's 0 minus 6, and then minus 5 minus 5, we get 0. So the 7x drags down, and that's negative 11. So then divide by 7, divide by 7. This isn't 0. That's why I hate the word cancels, because sometimes students get confused. 7 divided by 7 is 1. And so that 1 I don't write, it's implied. 1x equals negative 11/7. That doesn't simplify. Those numbers are both prime, 11 and 7, so we leave it. All right, next problem. Here's the beast. Here's the beast. I do not want to work with this many fractions. One fraction? Sure. Here I could have cross multiplied. I don't want to work with this many fractions. I want to clear the fractions. So I will multiply every single term by the LCD. Here's the only hard part, finding the LCD. Here's my denominators, 3, 2, 4, and 6. What's the LCD there? Some of you can quickly spat off, oh, 12. Okay, that's great. That's awesome for you. But remember, if you can't, then you look at the smallest denominator here, 2. 2 is the smallest of the numbers in the denominator. And you start thinking in multiples of 2. 2, 4, 6, 8, 10, 12. Okay, and you go through those numbers until you find a number that all of these other numbers can divide into. So when I look at 2, does 4 divide into 2? No. Neither does 6, neither does 3. Then I go 4. Does 4 divide in? Yes, it does. But does 6? No. Does 3? No. So I can't use 4. Then 6. Does 6 work? No, 6 doesn't work because that number. Okay, and then 8. Does 8 work? Well, no, that. Then 10. No, 10 won't work for any of these numbers. None of these numbers divide into 10. Then I get to 12, and bing, 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 bing. 12 is it because 3 divides into 12, 2 divides into 12, obviously, 4 divides into 12, and 6 divides into 12. So 12 is my LCD. So remember, I multiply every single term by 12. Okay, so here's the deal. When you do that, don't forget, this is a minus sign in between these two terms. Okay, so it stays on the outside of the multiplication. Same here. This is a minus sign separating these two terms, so it stays on the outside. That negative sign belongs to that guy. It's not a minus sign. That's a negative that belongs to this guy. That's a minus sign, so it stays on the outside. Whatever separates the two terms, whether it be a minus or a plus, that stays outside. Okay, and remember here, these are all 12 over 1, really. You don't need to write it unless it confuses you, and if it confuses you, then write it, okay? So here, of course, like I've told you before, I simplify before I multiply. So 12 and 3 can simplify. This becomes 4, and this becomes 1. 12 and 2 can simplify. This becomes 6, and this becomes 1. 12 and 4 can simplify. This becomes 3. This becomes 1. 12 and 6 simplifies. This becomes 2. This becomes 1. Wow, this is beautiful. Here I have 4 times 2. Remember I talked about earlier that x is in the numerator. 4 times 2 times x is 8x. And the ones on bottom are not necessary. Remember that's a minus sign in between these two terms. This 6 times 7 becomes 42. The ones on bottom aren't necessary. Don't forget to drag down that equals sign. Okay, 3 times negative 1 is negative 3. The ones on bottom aren't necessary. And then that's a minus sign. 2 times 5 times x is 10x. The ones on bottom aren't necessary. So now again, I have the same problem where I have x's on both sides, so I need to get them together on the same side. The bigger of the two coefficients, I've got 8 and negative 10. That means I'm moving to the left because I want to get to the side with the biggest coefficient. So that means I'm going to add 10x to both sides. Okay, I'm going to add, because negative 10, positive 10 is 0. So that's gone. So then we have 18x minus 42 equals negative 3. Okay, so then add 42, add 42. Oh, I don't want to write that equal sign in between there. Okay, so that's 0. So 18x equals 39. Okay, divide by 18, divide by 18. Okay, that's 1x. Oops, why am I writing it? I should just say it and just write x. So 1x or x equals, here's the deal, 39 over 18 simplifies. Both of those numbers are divisible by 3. So 3 goes into 39 13 times, 3 goes into 18 6 times. There we go. All right, last problem here of this type. So here, PEMDAS, we have no fractions. Thank our lucky stars, right? No fractions, but we have to remember PEMDAS. We've got to take care of this distribution, the multiplication, before we can worry about combining like terms. So this 3 distributes in here, 3x minus, I almost wrote 4, 12 plus 5 equals that negative 7. It just drags down because you can't add or subtract until you get rid of this negative 1 multiplying here. So negative x plus 2. Then I can combine some like terms on each side. So here I've got 3x minus 7 equals, here I can combine these like terms. That's going to give me negative 5 minus x. Again, I've got x's on both sides of the equal sign. I want to get them on the same side. Bigger of the coefficients is on the left. So I'm just going to go ahead and get everything on the left here. My x is on the left. So that's 4x minus 7 equals negative 5. And then add 7, add 7. So I've got 4x equals 2. Be very, very cautious here. Okay, I didn't really do my line in between. I should have. Here I've got 1x or x equals 1/2. Be careful, it's not 2, it's 1/2. All right, so are we ready to move on to back to the front? Let's get her done. Okay, let's finish this up. So graph, x equals negative 1. If you have just a single variable equals a single constant, a number, okay, then that's going to be a straight, either vertical or horizontal line, depending upon the variable. Okay, so this is x equals negative 1, so that means we're going to cross through the x-axis at negative 1. And in my class, you're always going to use a straight edge for that line. So I drew a couple of dots. Actually, I drew about 5 dots. And now I've got x equals -1. Every single point on this line has an x value of -1. Wouldn't you agree? That point there, -1, 5, has a x value of -1. This point here, -1, -6 or 7, I think it is, has an x value of -1. So that tells you which axis it crosses through, and that tells you the value it crosses at. So here we've got a variable equals a constant again. So this is y, so that means we're going to cross through our y-axis at +3. So again, I'm going to draw a couple of dots. And then, of course, I'm going to use my straight edge. And, of course, just like I did on the previous line, I'm going to have arrows on both ends because this line doesn't just end because my paper ends. It goes on forever, okay, into infinity. So here we've got y equals 3. And, again, pick any point on this line, and the x value will be something, who knows, but the y value will always be 3, no matter which point you pick on the line. Okay, now we get into something that you're very familiar with from Algebra 1. So this is your slope-intercept form, or it's about to be, slope-intercept form type line. We're going to put it in slope-intercept form. So we're going to solve for y. Okay, so we're going to get 2x on the other side, which the -y will stay, but that 2x, since it jumps across the equal sign, it's going to turn to a -2x, and that +7 stayed on the right side, so it stays +7. Of course, we don't want a -y, we want a +y, so that's where we divide every single term by -1. So this becomes y equals +2x minus 7. And then we are, in fact, in that y equals mx plus b form, okay, where m is the slope and b is the y-intercept. So -7, 1, 2, 3, 4, 5, 6, 7 in the negative direction. And then +2 is my slope. And remember, think of that as 2 over 1 because we've got rise over run. So since it's a positive slope, we're going to go in the positive direction. Up 2, right 1, up 2, right 1, up 2, right 1, and get enough dots to where you think you can draw your straight edge at least 3. And I can also go down 2, left 1. Why can I do that? Because down is a negative direction, left is a negative direction, and a negative over a negative equals a bing, 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 positive. So that is why you can go either in 2 positive directions or 2 negative directions, because either way that makes a positive slope. So this is your y equals 2x minus 7 line. Okay, last one. Sorry, I'm getting through it. So again, you got to get y by itself. Move over that 1/4, so we've got 2y equals -1/4 x minus 10. Okay, and then here, don't make the horrible mistake of dividing by 2, because then you're going to have to worry about a fraction divided by an integer. Yuck. Instead, why don't you multiply by the reciprocal? The reciprocal of 2 is 1/2. And what you do to one term, you've got to do to all your terms here. So I know it's kind of squished. 1/2 by every single term. So 1/2 times 2 is 1. Of course, the 2's turn to 1, so this is just y equals, this is going to become -1/8 x. Remember, make sure that x is in the numerator. And then minus 5, because 1/2 times 10 is 5. So then here's our equation. Now let's graph it. So we go down 5, 1, 2, 3, 4, 5, because that's our y-intercept, and then we have a negative slope. So we're going to go in the negative direction just once. Okay, what do I mean by that? Well, if you rise 1, then you're going to go left 8, because rising is a positive direction and left is a negative direction. So up 1, 1, 2, 3, 4, 5, 6, 7, 8. However, if you fall 1, then you'll go right 1, 2, 3, 4, 5, 6, 7, 8. Because falling is a negative direction, going right is a positive direction. You want to go in one positive direction, one negative direction. Think about it. You can't go in 2 negative directions because 2 negative directions would create a positive, and that slope is negative. So, and again, always check yourself. If that's still confusing to you, either 1, see me, or 2, check yourself. From left to right, that slope is falling. That graph is falling. From left to right, this graph is rising. It's a positive slope. It should. This is a negative slope. It should fall. Thanks for joining me.